This opens tutorial 6, Exploring Muscle Properties. So in this tutorial, we're going to explore the muscle properties by building a simple two-segment skeleton with a hinge joint and a pair of antagonist muscles. So to get started, we're going to launch MSMS. And we're going to go to File, New Model, and we're going to add segment. So the name of the joint is going to be shoulder. It's going to be a type weld. So this will keep the shoulder at a fixed position, so there will be no motion at the shoulder. And we're going to name the segment humerus and select OK. We're going to add another segment. We're going to choose the humerus as the parent segment. This is going to be an elbow joint. And we're going to leave it as a pin revolt. Now we're going to offset this by negative 250 millimeters, and we're going to name this segment ulna. And we're going to select OK. So now we want to go to the Model Explorer panel, and we're going to expand joints. Double-click on the elbow, go to the Axes tab, and we're going to adjust the rotational axes. We're going to limit the minimum angle to 10 degrees and the maximum angle to 160 degrees. And we're going to default the angle to 90 degrees. OK. Go to the passive joint moments, change the damping factor to 0.01. Make sure the low limit and the high limit are both active. This will be important for when we simulate the model. And let's just change the newtons per meter to 100 for both of the low and high limits. And we're going to select OK. So now we're going to double click on the ulna, go to the image tab, select the image and click edit. Go to the position and orientation, and we're going to translate this along the y-axis to negative 120 millimeters. So note that translating the image does not change the joint axes. The joint axis is controlled by editing the joint. And we're going to click apply. So here in the 3D window, we can see that we offsetted the ulna. What this does is provides an equivalent of the olecranon process on which we're going to attach the tricep elbow extensors. So we're going to click OK and OK. So now we're going to zoom in on the model. Let's remove the ground axes and center it. So we're going to add a muscle, and in the 3D window, we can see that we activated the muscle creation wizard. We're going to click on the humerus at the point where we want the origin of the muscle to be. And we're going to drag the muscle to the insertion on the olecranon process of the ulna and release. So for the first pop-up window, we're going to name this muscle triceps. And click OK. For the second pop-up window, we're going to check both of these features, energetics and proprioceptors. And we're going to change the fiber composition to 0.4 for the slow and 0.6 for the fast. And click OK. Double-click on the triceps. Go to Morphometry, and we're going to change the optimal fascial length to 7.1, the optimal tendon length to 15.3 centimeters. So what we're doing here will increase the pennation to compensate for the relatively short moment arm of the triceps. And we're going to click OK. So now we're going to add another muscle, and we're going to drag it down to the insertion on the ulna. And when we release it, we're going to name this muscle biceps. OK. Check both energetics and proprioceptors, and we're going to do the same thing. Change the fiber composition to 0.4 for the slow and 0.6 for the fast. And OK. So now we want to save this model. So we're going to go to File, Save As, and we're going to browse for the Tutorial 6 folder. So we're going to save this model as stick. So now we want to give the stick model the appearance
check the
of
Save
a
Main
skeletal
Library Images
model and click OK. So we're going to double click on the humerus, select the image tab, and under visible, we're going to uncheck the image. So we can see in the 3D window that the segment for the humerus disappeared. Now we're going to click add, and we're going to name this image humerus. We're going to browse under the mesh files, and we're going to look for humerus underscore r.asc in the tutorial 6 folder. So this is the image that we want. Select it and click open. So we can see in the 3D window that it replaced the stick segment with an actual image of the ulna, but we can see that the scaling is a little off. So we're going to go to scaling. We're going to scale it 90% along the y-axis. Go to position and orientation, and we're going to translate this image -9 millimeters about the x-axis and 7 millimeters about the y-axis. Okay. And okay. Now double click on the ulna, and we're going to do the same thing. Go to image, unselect the visibility for the image, and we're going to add an image. To add a new image, we're going to name this image ulna and browse for the ulna image. It's also located in the tutorial 6 folder. It's also located in the tutorial 6 folder. So select it, open, and we can see that the image is updated in 3D window. So we're going to go to position and orientation, and we're going to translate it 15 millimeters about the x-axis and 7 millimeters about the y-axis. And we're going to select OK. So now we're going to select the triceps, and we can see that the constraint points is activated. We're going to click on the constraint points, and we're going to drag each of the points to the closest bone surface. We might need to zoom in a little bit so that we avoid the axes. And we're going to do the same thing for the biceps. So now we're going to save this model as a skeletal model in the tutorial 6 folder. Check Save Main Library Images. OK. So now we want to save a simulation of this model. So we're going to go to File and Save Simulation. Now we're going to need to launch MATLAB. Now we're going to browse for the tutorial 6 folder. And we're going to click on the model folder and open. So we're going to double click on skeletal.mdl. Now we're going to click on the library browser. Double click on sources. We're going to grab the pulse generator and we're going to place it into our Simulink model. And we're going to do that one more time for the excitation biceps. So we're going to drag the input into the excitation biceps. Okay. And we're going to click this other pulse generator into our excitation triceps. We're going to name this one triceps. And we'll name this one biceps. Okay, now we're going to double click on biceps. Change the amplitude to 0.5. Change the period to 2 seconds. The pulse width to 50% of the period. And we're going to change the phase delay to 1 second. Click OK. Double click on triceps. And we're going to change the amplitude to 0.3. Leave the period as 10 seconds. Change the pulse width to 50%
Now we're going to double click on the
period,
human driver.
and we're going to make the phase delay 4 seconds. Okay. And open the library browser again. This time we're going to go to Syncs, and we're going to grab scopes and place it into our Simulink model. Let's make this a little bigger. Double click on it. And we're going to go to the parameters setting. Change the number of axes to 4. And we're going to data history and uncheck limit data points. Click OK. And we can see that there are 4 graphs now instead of 1. And we're going to close this. Let's copy this and let's paste this over here. So there's 4 inputs. We're going to take the first one and place it on the excitation biceps. Second one on force. Oh, sorry. And we're going to take that one there. And this one there. And we're going to do the same thing for the excitation triceps. Okay. We're going to name this biceps 1. And we'll name this triceps 1. Okay, now let's open the scopes for both of the biceps and the triceps. And we're going to play the Simulink model. Okay, so now we're going to go back to the MSMS model. And we can see in the 3D window that the model is being simulated by the Simulink model that we just ran. And if we go back to view the biceps and triceps graphs, we can see that the data is being recorded and updated in both graphs as the model is being simulated. So this concludes tutorial 6, exploring muscle properties.